What if right now the sun simply vanished? Not exploded, not dimmed, just gone instantly. How long do you think you'd actually have before you noticed? I'm Scott and welcome to Discovery Reel. The sun is 150 million kilometers away. Light from it takes about 8 minutes and 20 seconds to reach Earth, which means if the sun disappeared this very second, you wouldn't know it. You'd still see it shining for over 8 more minutes. Then, without warning, everything would change at once. The sky would plunge into absolute darkness faster and more completely than any night you've ever experienced. No twilight, no gradual fade, just instant total blackness. But sunlight isn't the first thing you truly need to worry about. Gravity is. The sun's gravitational pull is what keeps Earth locked in orbit. Without it, Earth would stop curving around a central point and instead fly off in a straight line into the depths of space. Remarkably, according to general relativity, changes in gravity also propagate at speed of light, meaning Earth would continue orbiting normally for those same 8 minutes before suddenly flying off into the darkness in a straight line, exactly when the light disappeared too. Temperature would fall dramatically, but not instantly. Earth retains heat, so initial cooling would be gradual. Within a week, average temperatures could drop below freezing. Within a year, estimates suggest Earth's surface could plummet to around minus 73 degrees Celsius. Photosynthesis would stop within hours of the light vanishing. Most plants would begin dying almost immediately, collapsing the base of the entire food chain in a matter of days to weeks. The oceans, holding enormous amounts of stored heat, would take much longer to freeze completely. Some models suggest a layer of ice could take over 1,000 years to fully seal the ocean's surface, though survivable conditions on land would end long before that. Human survival would depend almost entirely on stored energy. Nuclear and geothermal power could theoretically sustain small underground or enclosed communities, but large-scale agriculture and most current infrastructure would collapse within months. Eventually, Earth would become a frozen, dark rogue planet, drifting endlessly through interstellar space with no star to orbit. Its surface locked in permanent ice, its atmosphere potentially frozen solid over extremely long timescales. This isn't purely science fiction. Astronomers have already discovered real rogue planets, worlds drifting through the galaxy with no host star, potentially numbering in the billions across the Milky Way alone. The good news, this exact scenario is essentially physically impossible. Stars don't simply blink out of existence. The sun will continue burning steadily for roughly another 5 billion years before eventually expanding into a red giant. When that far future event does happen, the sun will grow dramatically, like engulfing Mercury and Venus and rendering Earth completely uninhabitable long before it ever reaches a sudden, instant ending. Scientists studying stellar evolution use exactly these kind of scenarios, even the physically impossible ones, to better understand the delicate, precise balance that allows a planet like ours to sustain life at all. Every single day, an ordinary sunrise is actually an extraordinary, precisely balanced event. One small star 150 kilometers away, quietly making every single form of life on this planet possible. If the sun vanished this instant, you'd still see the shining in the sky for another 8 minutes and 20 seconds, the time it takes sunlight to reach the Earth.